Hi guys, Mr. Johnny here. In this video I want to talk about this soldering station again. First off, I'm gonna show you how it looks inside. I did rewire it a little bit. Mains wiring looks somewhat similar, but I redone it a bit. This blue wire, by the way, you see there, is the earth ground on the IEC socket, which is connected to the ground on the secondary side. Also, I did install heatsinks there, as you can see. This is bloody obvious, but that one is quite hiding there. And the switch and the fuse is on the live side now, on the hot side of the AC, assuming you plug the other end of the cord right. I marked my outlet so I know how to plug it in correctly to have the correct phasing. Anyway, so the problems. First problem is that it doesn't really want to start up sometimes. Sometimes it refuses. And that is because it requires quite a large load to be present on the output to start up reliably. And that's pain in the ass, because you can do it very simply by just whacking a resistor which will dissipate like a watt or two on the output, and it will be connected permanently. It will dissipate one, and you will have 1 or 2 watt heater inside of this enclosure which has no ventilation holes. Not so great, is it? So I decided to go a little other approach. Added a little bit of circuit there in the electrical tape, and that circuit looks something like this. Just a little delay circuit. 2 transistors, really. The resistor which is going to be connected act as a load. It will be connected to the output via this transistor, and that transistor will be on for a short period of time until this capacitor charges. So when you plug it in, this capacitor is discharged, so this transistor is off, and this transistor is on through this 4.7K resistor, connecting this 220 to the rail. Then slowly this capacitor charges up. Eventually it reaches a big enough voltage here to turn on this transistor and turn off this transistor then, and then the load, this resistor, is disconnected from the output. This way I have the dissipation only on the startup, which should be enough, but right now this kind of values give me about 1 second delay, and that's not enough apparently. Apparently I need a larger load and a longer delay, something like 3 seconds and about 3 watts. That's quite crazy. Yeah. So I actually have a hunch why it does that. I did forget to install some resistors in the board, but luckily I can easily hack them onto the existing pads, and they will look more or less like they belong there, so it won't look very tacky. So I will do that and report to you in the next video whether it did help or not. Anyway, next problem is again mine problem. I didn't install heatsink there. They are electrically isolated, as you can see. Insulation washer, this silicon pad. So this is electrically isolated, and so is the secondary heatsink there, which you can see bends around there. This poses no trouble really, but this, even though the flange there of the TO220 package is a cathode, right? And it's not particularly noisy switching node. There is some noise there anyway. And even though I have it isolated by the same method, a washer and the silicon pad, there is still, I created a capacitor pretty much. The flange is one plate and the heatsink is another plate. And there is some noise being capacitorly coupled onto this heatsink and acts as an antenna. I have to say to you that honestly, I did expect this heatsink to cause some problems, and it definitely does. The problems is that if I leave it as is, not connected to anything, the readings jump around on the display quite a lot until I go and ground this heatsink. Again, it's electrically isolated, I can connect it wherever I want. I chose to connect it to 0 volt, to the ground of the secondary side, because again, the ground of the secondary side is also connected to the earth ground via this wire. That way, the problem is fixed. Another problem. Now, it's not my problem, not a problem I created, but a problem which exists in these controllers as a whole. This blue board is what I'm talking about. You saw that in the previous videos. So what's wrong with it? First, a little preamble. I went and, as usual, browsed YouTube, watching some videos, and I found one Russian YouTuber complaining about that his station, not this one, he just bought the kit without the enclosure, made his own enclosure or whatever, doesn't matter. He has the same kind of T12 kit, and he complains that the iron got red hot. And the iron got red hot because the MOSFET which is used there shorted out. Why did it do that? Well, the MOSFET installed there is D409, in the version that I got at least. And that's about 50, more than 50 volt drain to source voltage and over 10 amps, more than 10 amps of drain current, so it's not a problem really, because you have 24 volts here and 3 amps. Seems to be safe, right? But what's the problem? Well, the guy there used the very simple approach, the bigger the better, and replaced the burnt transistor with one which is rated for more current and more voltage, not actually troubleshooting what is creating the problem as such. I did a little bit of reverse engineering, and I found out that the output section looks like this. You have your p-channel MOSFET, which connects your cartridge. Yes, it has a thermocouple and the heater in series, a bit weird, but whatever. This MOSFET connects 24 volts to your cartridge to whenever you want heat. This resistor makes sure that the MOSFET will be off when this transistor is off. When this transistor is off, you have an open circuit there, and this resistor will pull the MOSFET gate to the same potential as the source is, so the transistor will be off. Nice. Now, when the microcontroller wants to turn on the heater, it puts a logical one here, which turns on this transistor, and effectively this tranny connects this gate of the MOSFET to ground via 470 ohm resistor. Seems hunky-dory, right? Yes, it does, until you go into the datasheet for the MOSFET and see that the maximum allowable, absolute maximum rating of gate to source voltage is 20 volts, one way or the other. I mean, both polarities. It can be plus 20, minus 20, it doesn't matter. Polarity does not matter here, the amplitude does. So the absolute maximum rating is 20 volts. And obviously, if you have 24 volts here, when this transistor switches on, it's not a junction really, it's just a capacitor. So it will charge up and to the full voltage that's applied to it, which is 24 volts now. And that is 4 volts higher than the absolute maximum rating. Not good, is it? I'm not sure is it 100%. Not sure if this problem is a 100% culprit here, but it certainly looks crikey. Any MOSFET that I saw the datasheet for has a plus minus 20 volts allowable voltage on the gate source. So easy fix is to cut one trace right here and add a little part in there, which is a Zener diode. You can use 12 volt Zener diode, doesn't have to be anything fancy, just 12 volt half a watt Zener diode. So it's nothing fancy really. The track you need to cut is, let me try to show you this. Here is your MOSFET. Here is your gate, as you can see, gate, source and the drain. And this little dimple is the drain as well, but it's not used, it's really an kinda like appendix. So here you can see this 2.2K resistor, hopefully, which is make sure that this transistor is off whenever this transistor is off. And that's that NPN transistor you saw in the schematic. That bastard right there. So what you have here is, let me try to show it. Sorry for handheld footage, I can't really get as close with the mount. You can see that the collector is connected to the via, so that has a trace on the other side, which snakes around and connects to this via. So what you can do is you can go and take an X-Acto knife and cut this little track which goes to the from the via to the resistor, and then solder a Zener diode cathode here and the anode here to the collector, and that will be a fix. Easy fix which will make sure that your transistor will be fine and dandy. At least I think that will help. Well, it will help definitely, because again the datasheet calls for an absolute maximum value of 20 volts. And you're applying a 1 which is 4 volts above that. And as they say in datasheet, operation above those values are not the reliability of the device operating at those values or higher than them is not guaranteed. So that's that. Now let me show you that the reading jumps around with this heatsink not grounded. By the way, if you're wondering what this wire is, it just connects to the board there and to the barrel jack on the outside, which has a diode there to prevent the power supply backfeeding into this socket. I don't want that. I just want this socket to supply power, not to take power from the power supply. You might think of it as a disadvantage, but whatever. The power supply is in fully enclosed case, so it's running quite not great. It's not a great idea to put even more load on it. Having said that, it runs extremely cool if you ask me. The heatsinks get just barely warm. The efficiency of this converter is pretty decent. On 20 watt load I measured it at 90%. Yeah. And that is with the primary snubber installed and the secondary snubber installed. And have in mind please that those snubbers convert that ringing, they absorb that resonant oscillation and dissipate it as heat. So you lose some efficiency by installing this, but you gain a cleaner waveform and lower EMI. Yeah, let me show you first. I'm gonna plug it in, show you that it won't really start up. Then after it will, I'm gonna show you that the reading will jump around unless I ground this heatsink. Okay, let me turn it on and see whether or not it will start up. Sometimes it will. Ah, you mofo! Look at that. It started up. But trust me, sometimes it refuses to do that. It actually depends on where exactly you switch it on. If you happen to switch it on right when the sine wave is on its peak, it produces a big enough surge in the primary side to kick the oscillator into going just fine. But if you happen to be a zero voltage switching dude, if you switch it when there is 0 volts, you have no arc inside the switch. That's great, but the oscillator will not start up then. Anyway, let me show you the jumping around. Let's set it to about 300. Well, that's what you see there. Yes, there is some ticking noise there whenever the load is applied. Well, that's nothing bad actually. I kinda like that. It's not annoying, it's like... it's fine. Now, what I'm gonna go is I'm gonna use this piece of wire, jam one end into the JST connector there, and hook the other side onto the heatsink, and you will see that the temperature will be stable then. Okay, let me try to do it without shorting anything out. See? Rock solid. It will jump around a little bit because you can see without and with. Eventually, even with the heatsink grounded, it does jump around a little bit, especially when you put the iron onto some large power plane. But that is actually nice, because that means that the temperature I see here is the real temperature, unlike this station. This station kinda shows me the whatever it's set to, really. That is, of course, also a problem. That might not be the case. The case might be that the station, indeed, this one, shows me the real temperature, but the problem is that it shows me the real temperature of the heater, not the tip, because again the thermal coupling between the heater and the tip is quite poor in these 900M series irons. You can see the thing went to sleep there. The controller on itself, with the iron, with the handpiece disconnected, draws about 700 milliwatts. So even when the iron is disconnected, the power supply does have some load, minimum load to supply, and it will be fine. But again, sometimes it refuses to start, so I'm gonna go take it out, unfortunately. Again, I was a bit too fast about it, screwing it in place, but oh well. I'm gonna take it out, put those two resistors that I think is the problem, check again, check it for a couple of days after it's been checked number of times, so I know for sure. Anyway, that's that. Enough for this update, it's 18 minutes already. Thanks for watching, see ya.